Hey guys, today we're going to start talking about triangles. So triangles, we might know what they are. They look like this little shape over here. Triangle, we say, is a figure formed by three line segments that intersect at their endpoints. So an example of a triangle looks like this. So this is a triangle, has three line segments that intersect at their endpoints, and we could call it D, E, and F, those endpoints. Now the parts of the triangle, each segment we would refer to as a side of the triangle. So this is side DE, this is side EF, this is side DF. And each endpoint that these segments meet at, we would call that a vertex of the triangle. So this would be like the vertex D, vertex E, vertex F. Notice with a triangle, the word tri means three. You have three sides. You have three, we call them vertices. It's a plural of vertex. And you have three angles. One angle formed at each vertex. So the angles that fall on the inside of the triangle, they have a special property to them. We might know that they add up to be 180 degrees. If we don't know that, then we will talk about that in a second. But first, let's talk about notation. So if we want to notate that we're talking about a triangle, in this case triangle DEF, we would simply draw a triangle and write DEF. By using this symbol, that means we're referring to this whole shape, this whole, we call it a polygon. So we're talking about the triangle now. Now in the future, the order that we write these three vertices is going to matter. It's going to be really important. But for now, we're just going to list our three, but make sure we're using the triangle symbol here. So this is how we would notate this triangle, triangle DEF, because if you go from D to E to F and come back to D, you're going to make the triangle. And we'll talk more about this notation when we get to other topics with triangles. But for now, just know the symbol of a triangle. So one of the important properties I just talked about is that the angles inside a triangle, they add up to be 180 degrees. So the example I have in your slides, we have X degrees over here, Z degrees, and Y degrees. So there's a few different ways you can go through, like proving this. There's some cool proofs you can look up online. But right now we're just going to say that the angle X, whatever this is, can be anything, less than 180 degrees. But the measure of X plus the measure of Z plus the measure of Y, so X plus Y plus Z, equals 180. And the reason why we have three different variables is because the variables or the angles, they don't have to measure the same. These could be three completely different measurements, but they have to add up to be 180 degrees between the three of them. And this is what we're really going to focus on today. This is called the interior angle sum theorem of a triangle. Basically just means that the angles inside a triangle are going to add up to 180. So we'll go through a few examples of this, and we're just going to stick to this property. But the problems can get a little bit harder, and we'll do some harder ones as we go, but it's all about you have to add up to 180. So the first example that we have a nice triangle, looks something like this. This is the third slide if you're following along. We have this angle measures 119 degrees. This angle measures 30 degrees, and this angle is just called B. And our goal is to find the value of the variable and then the value of the missing angle. So for this, we have two of the angles of the triangle. We don't know the third, so we know that 119 plus 30 plus B has to equal 180. The three angles have to add up to be 180. When you add together here, we get 149 plus B equals 180. Just solving an equation. When you subtract 149, you should get B is 31. So our value for the variable is 31, and this angle was just represented by B, so it would have a measurement of 31 degrees. So there was our first one. Simple enough. If you're missing one angle, just add everything together, and it should equal 180. We'll try another like this. It's really important to set up the equation, because some problems are going to be harder than just being able to figure it out really quickly. So our next one, our triangle looks like this. We're given 62 degrees down here, 30 degrees up here, and x down here. And we want to find the missing variable and the angle measurement down here. So we should just say 62 plus 30 plus whatever x is has to equal 180. The sum of these three angles should equal 180. So when we add together, we should get 92 plus x equals 180. Get your x isolated. So when you subtract, you get 88. Let's make that legible. So x equals 88. And since this angle is just represented by x, that means this angle has a measurement of 88 degrees. So those are some of the more simple examples. Now we'll get into some that can be a little more challenging. We'll get a little harder as we go. So our next slide, slide 5 here, we have this example. We have a triangle that looks like this. We're given that this angle has a measurement of 40 degrees. This angle has a measurement of 100 degrees. And this angle has a measurement of 5w. So it's not just a regular old variable, now it's 5 times the variable. But still the same concept is true. When we add these three angles together, it should equal 180. So 100 plus 40 plus 5w is going to equal 180. And the reason why I'm setting up an equation each time, it's good to get in that habit, because there's going to be some questions you can't see right away, and setting up an equation is going to be the way to go. So let's go ahead and combine like terms. 100 plus 40 plus 5w is 180. Subtract 140 from both sides. So 5w should equal 40. When you divide by 5, your value of w is 8. Now if you want to know the measure of this angle, well, you would do 5 times 8. 5 times w equals 40. So this would have a measurement of 40 degrees down here. Also 5w equals 40, which is kind of right for us right there. And there's your value of w, your value of the angle, and we're all done. So let's move on to one that's now getting a little bit more difficult. This is our 6th slide. Our triangle looks like this. Here we go. We are given that this angle has a measurement of 44 degrees, and that's the only angle measurement that we're given. We're given this angle is c plus 6 degrees, and this angle is 4c, the degree symbol if you want. So these three angles have to add up to 180. That still is true. That property still is there. So let's just write what we have. 44 plus, so this angle, plus 4c plus c plus 6. Well, that's the three angles. Even though two of them are expressions, that's still the three angles. That has to equal 180. Now if we combine some like terms, 4c plus c is 5c. 44 plus 6 is 50. And we still have the 180 on the right. Now we're just solving an equation, just like we've done for many months this year. Get your c by itself, you have 5c, you have 130 over here to the right, and then when we divide by 5, we should end up with c is equal to 26. So our value of c is 26, and if we want to find the angle measurements, well, over here, c is 26, so 26 plus 6 is 32. This angle has a measurement of 32 degrees, and this angle has a measurement of, well, c is 26, so it's 4 times 26, and 4 times 26, we should end up with 104, so this angle has a measurement of 104. And just like that, we're all done. So some problems get a little bit harder, but you're still going through the same process. Set up a nice equation, and then just solve the equation. Even though you have like terms, you can still combine them. So it's going to lead us to our last problem, where we're going to be given none of the angle measurements. We're going to have to find them all, just expressions here. So our last example is a triangle like this. Draw it nice and big. We have w minus 5. We have w minus 37, and we have 2w minus 46. So we know none of these measurements. We just have an expression for each one. But we do still know that whatever these angles are, they have to add up to be 180 degrees. So let's write what we know. W minus 5 plus 2w minus 46 plus w minus 37, and solve the equation. There's a lot going on over here, but it's all skills that we know how to do. Add your w's together, your like terms. W plus 2w plus w is 4w. And we're dealing with some negatives, but that's okay. You have negative 5 minus 46 minus 37. So negative 5 minus 46 is negative 51 minus 37. That's going to give you negative 88 over here. And that equals 180. Get all of your constants to one side. So add 88. So 4w, when you add 88 to this, you're going to end up with 268. And then you just need to divide by 4. So you should end up, when you divide by 4, with 67. And then you have your value of w. So we found the value of the variable. Now if we want to figure out the angle measurements, well, down here you would do 67 minus 5. So this angle has a measurement of 62 degrees. That would be this angle. This angle is 67 minus 37. So when you subtract, you should get 30 degrees. That would be this angle measurement. So 62, 30, and you could substitute in to find out. You also could add the two measurements together and subtract from 180, because it should add up to 180. Let's say you multiply by 2 times 67, and then you're going to subtract 46. So 2 times 67 is 134, minus 36 is 88 degrees. So this angle should have a measurement of 88. If you want to check to see if it's correct, take your three angle measurements, add them up. 88 plus 30 plus 62. When you add them up, you should see that you're going to equal 180, as it should, and then you're all done. So your value of w is 67, and your three angles were 30 degrees, 62 degrees, and 88 degrees. Alright, that's all we have for today. Tomorrow we'll talk about how to classify triangles. Have a nice day, guys.